So the second topic of today is ultracapacitor. So I'll just touch briefly on it as well. So what ultracapacitor is basically does, it has a very fast charge and discharge response. So as you can see in this picture over here, this is the rechargeable battery. So the time it takes, and this is the time axis. So the time it takes to charge and discharge, as you can see, is very long. But when it comes to ultracapacitor, you can just charge and discharge it in microseconds and milliseconds. Uh, so this makes it very efficient for when it comes to harvesting the regenerative braking energy and for supplying peak power. So when you go on the accelerator pedal really hard and you want to accelerate very quickly, the ultra capacitor is then able to provide a lot of power instantly to provide that sort of acceleration. So that's why it's been used in features like stop start and regenerative braking. There are over 2 million vehicles on the road right now that our work have this stop start developed by the Continental Automotives, and they have Maxwell ultra capacitors in them. But what makes ultra capacitors behave differently than a battery? That the answer lies in its basic mechanism. So the batteries, they produce electricity by some sort of chemical reaction. Ultra capacitors don't really have a chemical reaction in them. So what they have is they have these electrodes and they have electrolyte, and they have a separator between this which separates the positive and the negative terminals of it. So the charge is essentially stored on these charge collectors, and so it is readily available to be discharged. So it doesn't have to wait for a chemical reaction to happen first, and then it has the current ready to be given to the system. So because it already has a charge stored on these terminals over here, it can just charge and discharge it very rapidly, and that's what makes the ultra capacitor really power dense compared to the batteries. So we have seen what the fuel cell vehicle does and how it works, and we have seen ultra capacitors. So then these things are used in the hybridization of a fuel cell. One of the disadvantages of a fuel cell, like I said, is its very slow dynamic response. So imagine having a vehicle just propelled by a fuel cell. So you are stopped at a traffic light and you want to accelerate. The fuel cell will not be able to provide enough power to accelerate the vehicle very quickly. And that's where the hybridization becomes really important. So if you have a fuel cell, you will most likely have some sort of energy storage device, like either a fuel cell and an ultra capacitor. You can have a fuel cell and a battery. And the third one is a fuel cell, battery, and an ultra capacitor. This makes it a triple power source topology because there are three sources of power: the battery, the fuel cell, and the ultra capacitor. And the essential driving part of it is a motor in all of these three. So you have these components over here that supply the electricity, and then through some power electronics it gets to the motor, and that's what propels the vehicle forward. So in this field, what are some of the job roles? So these are the job roles in entry level market. So you have modeling and data analysis engineer. So what this job essentially is that you create models of fuel cell, the vehicle, the powertrain, and then these models are supplied to OEMs where they want to use that for their simulation activities, because for simulation you need to have a model which is accurate to show what the physical system will actually do. And then you have a lot of, so what this modeling and data analysis engineer will do is that it will look at the data, and then it will try to identify the parameters of fuel cell stack and ultra capacitor, and then create a model of it to supply it to the customers. Packaging design role, this is basically trying to find the best available packaging for all the components, like the fuel cell, all the power electronics in it, the battery, the ultra capacitor, all the electric motors and things like that. So this is a very heavily CAD design based role. This design packaging uses softwares like Creo and SolidWorks, CATIA, and similar kind of softwares. Simulation engineer. A simulation engineer is essentially what uses the modeling data provided by the engineers, and then because it's not possible to test everything in a physical system where you have a fuel cell, you have a vehicle in which you can test. You do a lot of simulation on your computer. So you have a control software, and you have a model of the fuel cell or the model of the vehicle, and then you run that control system to check whether the control system is working as you require, and if not, then what's the deviation from the expected behavior and all those things. That's what the job of a simulation engineer is. Function developer. So I initially showed that there are many companies that provide softwares where you have to control all the parameters, where um, like hydrogen supply and temperature and water management and thermal management. So all of those things, those things are controlled by softwares written in MATLAB and maybe ASCII if it's a Bosch supplier as a supplier. Then all the MATLAB development that happens, that's what the job of a function developer is. So you'll develop functions in MATLAB to control all of those parameters. A system um, test engineer, as the name suggests, that you will be testing a lot of systems. So you will be given some sort of requirements that this is how it should work, and then you will go either in the vehicle or you will have a fuel cell system as a standalone, and you'll run the test. The test procedure will also most likely be given to you, and you'll be trained to do some of the tests. And then your job is to see what things are working correctly based on your tests, and what things are not working correctly, and then you have to work. If things are not working correctly, then there is some sort of problem with the software, so you have to work with the function developers. That's a job role previous to that. Then you'll supply data to the function developers telling them this is working fine, this is not working fine. So you work in collaboration with function developers to perfect the system. System integration engineer. This role is essentially for because there are multiple components in the vehicle. So integration engineer, what he or she really will do is to make sure that all the systems, when connected together, they work properly and there's no misalignment. So it's also a very interesting role because you get to learn a lot on the entire overall vehicle level as well as component level. High voltage system engineer. So you have high voltage components in the vehicle like the battery, and the fuel cell is also essentially a high voltage system engineer. So you have to design systems to make sure that the voltages are safe operation and all those sorts of things, all related to high voltage. So this is a very electric engineer intense job. And there is calibration engineer. So the function developers, when they make the softwares, there are a lot of parameters that they leave. So you need to do some sort of tuning for those parameters, and that's the job role of a calibration engineer. So they have some parameters and they'll change the value of those parameters, and based on that value, then you will get the best performance and the optimized performance out of that subsystem. And that's what the role of a calibration engineer is. And then you have a system design engineer. This is not a very common role for entry level engineers, but it's still possible. So what system design engineers, they do is that they create requirements. So they will tell the function developer that, okay, these are the things that need to happen in a car. And for system design engineers, you need to have a strong background and a very strong knowledge of the system you're working on. For example, if you're working on fuel cell, you need to understand the fuel cell and the electric powertrain in a decent shape so that you can actually write requirements. And based on those requirements, the function developers will develop the functions in MATLAB most likely. And that's what the system test engineers will test. So it's possible to get into the jobs as a system engineer, but it's not very, very common. It requires a bit more experience for entry level positions. Some of the job roles in senior level positions is a lead system engineer. So as you develop experience as a function developer, you can go on to becoming a lead system engineer where you design everything. Development engineer of fuel cells. So it's basically focused on developing fuel cells, and it will be a bit more electric and chemical engineering focused roles where you try to develop and improve the performance and the chemical reaction and things like that. Functional safety engineer. So as the name suggests, this engineer's role will be to make sure that all the operations of all the components in the vehicle are happening such that it's safe for the driver and the vehicle, and there are no dangerous operating conditions that are happening inside the car. A technical specialist. A technical specialist is essentially just is someone who has a very broad and very deep knowledge of the topic, and most of the lead system engineers and all the function developers, they consult with the technical specialist to make sure that they are doing things right, because the technical specialist will have a lot of knowledge and they can provide this feedback. And then you have the regular project managers, system design manager, where many system engineers report to the system design manager. And then you have the calibration manager, where you have manage a team of calibration engineers. Job roles and top management. So you have a principal engineer and you have chief vehicle engineer. These are like the topmost roles when it comes to automotive. So if, for example, if you take Toyota Mirai, the Toyota Mirai will have a chief vehicle engineer who's responsible for delivering the entire vehicle to the market. So that's a very high accountability role. And the same goes with powertrain and calibration department manager. So these people will be responsible for delivering the entire software for the powertrain, and with calibration and all the functions developed. And powertrain department leader is the similar role, where um, you have to make sure that all the components are working. So you are the leader for many job roles. Okay, now let's go into a case study. So peak power shaving with fuel cell hybrid electric vehicle with ultra capacitor. So I'm showing here a triple power source topology. So what it really means is that there are three power sources, like you can see on this side. So this topology is very complex for production vehicles, but this is a very good topic for academic research. There's a lot of research in combining these components like the battery and ultra capacitor, but it makes it not very fit for production because of its costs, its packaging. It can be difficult to put all the components in the vehicle, and its energy management and functional safety. So um, these components are complex to manage anyway, and the more you add, the more complex the powertrain becomes. So let's do a case study for this. So when you're developing systems for a fuel cell vehicle, you have I've only given 4 high-level main components of software. So you're developing software, like the function developers and the system requirement people, they will develop requirements, and then you'll develop softwares based on those requirements. So you will have, these are the 4 main, you can say, subcomponents. Fault reaction. So what fault reaction component in the software will do, it will monitor any faults. For example, if the hydrogen supply is low, what to do. If the voltage is going really low, what reaction to take. Should you open contactors? Should you limit the amount of current going out from the battery? So these kind of, so you will monitor, you will classify certain faults, and then you will classify what the reaction to those faults should be. And then similar to that is high voltage circuit monitoring. So you will monitor the voltage of the battery, the voltage of the fuel cell, and you will monitor the voltage of individual cells. And the component of the software has to make sure that the voltages never go too high or too low, so that it doesn't damage any of the components. Torque control and management. So when you go on the pedal, the way a vehicle moves forward is essentially by torque on the wheels. So that, because this is an electric motor driving the wheels, so the current has to come from some component so that you drive the wheels. And so a torque control strategies will essentially make sure that current is delivered to the motor in one way or another, because there are many other components like the DC-DC and the 12-volt battery, and those components are also requesting control the current. So the job of the torque control feature is to make sure that you can actually drive the vehicle in a decent manner. And energy management. So there is a fuel cell is one of the energy producing component. Then you have battery and the ultra capacitor. They all store energy, and there's a 12-volt battery. So the energy management component, it makes sure that there is always enough energy in the battery. And if the energy in the 12-volt battery is low, then the fuel cell will produce a bit more extra power to charge the 12-volt battery. Similarly, if the high voltage battery goes low, then this energy management component will tell the fuel cell to produce more current so you can charge the battery, and these kind of things happen inside energy management. So let's take one of those components and go into a little bit deeper case study of energy management. So in an IC engine, normal conventional engines, there is a sweet spot where the engine is the most efficient. And so a lot of energy engine control softwares try to operate that engine in that most fuel efficient region. So this graph that you see here is for the fuel cell system. So you can see that it's highly efficient in this area, just 60% efficiency. And when you operate the fuel cell in this range, which is 40 to 60% of its power rating. So the job of the energy management software is to make sure that you try to operate in this region, meaning when you try to request current, you make sure that it falls in this region, which is 50 to 60%, 40 to 60% of the power rating. And when you are not able to operate in this region, you have the ultra capacitor and the battery in the powertrain. So all the driving can be done by drawing current from the battery and from the ultra capacitor. So this sort of juggling between all the power sources and managing and making sure that the best component is used in the best scenario, that's what makes the energy management very important, and that's what can make the fuel economy more, so it can drive longer with the given amount of hydrogen. So like I was saying, you need to identify the best source of power for a certain power demand. So the way you can do that is you have a power demand, and then you can check how much is the power demand. These are just some example figures that I've taken. So if the power demand is between 0 to 9 kilowatt, for example, so basically this is very low power demand. And because the power density of battery is low, but the energy density is high, you can use the battery pack for that, because battery is suited for low power applications. So when you have a medium level of power demand, that's when the fuel cell can work, and you can operate that fuel cell in that best efficiency region, because it's medium power demand. You can draw current directly from the fuel cell and supply it to the electric motors. But when the power demand is very high, so when you're accelerating really quickly, you can use ultra capacitor. The ultra capacitor can discharge very quickly, and you can get all that instant power and accelerate the vehicle. But when you go into regenerative braking, it becomes a bit complex, because you have two components that can then harvest that regenerative energy. You have the battery and you have the ultra capacitor. So you need to come up with some sort of algorithm to make sure that you keep both of them charged, and then you just maintain it, harvest the energy very efficiently. So you can have some sort of algorithm for that. Now, how to get into this field? So one of the most common way to get into this field is by the function development route, where if you have good experience with MATLAB and Simulink, or if you have just basic knowledge of MATLAB and Simulink and some basic knowledge of the academic topic of it, then you can enter the field. And by developing functions, the more you develop, the more knowledge you'll develop, and then you can then progress to become either a system engineer or calibration engineer, if you like. And then function developers are in good demand with very big OEMs like Toyota and all the leading companies that are working and developing fuel cell vehicles, because like I mentioned previously, they do a lot of in-house software development. So if you do in-house software development, you need engineers to develop those functions. So that's why they can they either hire a lot of function developers, or they work with supplier companies like Bosch, and those companies hire function developers, but they are still quite a lot in demand these days. If function developing is not an option, then a test engineer is also a very good route to enter into this field, because you initially you just follow test procedures, but by following those test procedures, you can gather a lot of knowledge necessary for this field, and then you can progress in that career. And so if you already have a good technical background in fuel cell and automotive, then getting directly into systems engineering should be possible, because systems engineering is essentially a role with a lot of accountability. So if somebody is hired for that position, the company will just make sure that they are fit for the job and they have good technical background for that. A lot of the systems engineering is done outside of India. For example, most of the OEMs are not based in India, like you can see, but Tata Motors has developed a fuel cell bus, like I mentioned, and they have developed that with ISRO. Uh, so ISRO already had a lot of experience in hydrogen and fuel cell, because different kind of fuel cell has been used in spacecrafts for some time now. So just Tata Motors collaborated with ISRO and they developed a fuel cell bus. So in India, I think initially a lot of fuel cell buses and transportation sector will see more use of fuel cell initially, and then it will then further go into passenger vehicles. So it's just a matter of time when it will catch up. So we'll have to see which OEMs in India spend money in developing fuel cell powertrains. But on the other hand, you have companies like Log9 Material. It's a Bangalore-based company that has recently received a funding of $3.5 million, and they are trying to develop a fuel cell based on aluminum rather than hydrogen. So let's see where this goes. This is something new and interesting happening in Bangalore.